This video covers the ASTM and ISO scratch standard tests for the Surface Machine System's Scratch 4 machine. The machine is equipped with two physical power buttons, one for normal power operation and one for emergency stops. The emergency stop button is the large red button on the left side of the machine. Setting head height and correctly clamping samples is an easy process. Whenever loosening the head to adjust head height, make sure that an impact-resistant item is placed under the head, just in case of crashes, to prevent damage to the head or to the work surface. The stylus should then be placed in the head while the head is in the up position. Be sure to provide enough pressure to keep the stylus firmly in place, but not to have excessive pressure which might damage the scratch column. Lower the scratch head to within 1 mm of the surface. You can use a sheet of paper or a similar type of gauge to make sure that there is just enough clearance. Hand tighten the head clamp nut and then use a wrench to apply enough torque to make sure that the columns cannot adjust or move during testing. Apply firm but not excessive pressure. Clamps should be forceful enough to just hold the sample in place while under load, but not enough to cause damage to the clamp or to damage the plaque unduly. Additionally, you should ensure that all clamps are clear of the path of the scratch that the head will take during operation. A key issue with using the clamps is to make sure the clamps are as close to parallel to the surface as possible when they are applied to the plaques. Here we see there is plenty of space. You should always clear debris from the system prior to using it. We use an air supply in order to do this in our lab, although any other systems can work. We also recommend using latex gloves or other type of gloves that prevent getting oil on the machine. When running a test, make sure that the machine is on prior to turning the software on. You can use the File Open dialog to set the file where the data will get stored. This must be done prior to running a test. You can enter notes describing the type of test and the parameters used. Additionally, you can set the data rate or the material hardness constant. Set the scratch length, velocity, and start and end load of the test. Zero all data points prior to starting the test, and then click the Start button. You can use the Stop button if there are any issues. Jogging the head. It is possible to move the head laterally, left or right, by using the jog functionality in the interface. This can help to align the head under large or under several different types of plaques on the same work surface. The material hardness constant, or MHC, should be determined for each system under test. A spare specimen will be necessary in order to determine the correct MHC. A default of 220 is suggested for most TPOs or PPs. Starting from this value will get you close to the correct MHC. For polycarbonates or other hard systems, a much higher MHC may be necessary. Let's say we want to reach a test end load of 15 newtons. We should run a sample test against the system to see how close the MHC is. Once we have run the test, we can open the data file in Microsoft Excel or any program that allows us to visualize data. In Excel, we can create a graph of the data to inspect the end load achieved during test. Here we can see that the end load does not reach 15 newtons. We should raise the MHC, perhaps by 20 points, to 240 and run another test. We check the second test, and we see that the end load is too high. We should lower the MHC, perhaps by 10 points, to 230, and run another test. Here we can see the end load is very close to 15 newtons. We might want to raise the end load a bit, but we want to remain close to the target end load. Major differences in end load from ideal can result in different in situ strain during the test.